All right, strap in because today we're going deep on some serious cutting-edge AI. And I mean, we're talking AI that can diagnose medical conditions,
Oh, yeah.
not just by spitting out a quick answer, but by actually reasoning its way through a problem, like an actual human doctor would.
It's really remarkable. It's called inference-time scaling,
Yeah.
and it basically allows these AI systems,
Okay.
which are large language models or LLMs,
LLMs.
yeah, to really kind of dig into the nitty-gritty of a medical case.
Okay, so LLMs. Now, for those of us who don't exactly speak fluent AI, can you break that down a bit?
Sure, sure. Think of LLMs kind of like these super-powered language processors. They've been trained on just massive, massive amounts of data, which allows them to understand and generate text that's, very human-like.
Right.
They're kind of the brains behind things like chatbots that you see, and even some of the more advanced writing tools that you might be familiar with.
So how do these LLMs, how do they become doctors, so to speak?
Well, they need that specialized training.
Okay. On medical data, so things like textbooks, research papers, and even anonymized patient records.
Okay.
So this allows them to really learn the language of medicine and start to recognize those patterns and relationships between, symptoms, diseases, and treatments.
Gotcha. So that's where then this inference time scaling comes in,
Yes.
where essentially we're giving these Dr. LLMs more time to think,
That's
right?
it. That's it. Instead of just sort of matching patterns and spitting out, like you said, a quick answer, this inference time scaling lets that LLM really break the problem down into steps,
Uh-huh.
analyze each piece of information carefully, and then build this chain of reasoning.
So they're really saying, like, hold on, let me consider all the angles here before I give you a diagnosis.
Precisely. And this is so crucial for medicine because, as you know, it's rarely a simple equation.
Right.
Doctors have to consider the patient's entire history, their symptoms,
Yeah.
lab results, lifestyle. I mean, it's a lot to process. It really is. And, from what I'm seeing in these research papers, these sort of souped up LLMs, they're actually pretty good at it, right?
They really are. Yeah, one of the papers we're looking at today actually focuses on something called the O1 system.
Okay.
And the results are really impressive. They tested these AI models on some pretty tough medical challenges. Like,
Yeah.
we're talking benchmarks like MedQA and MedBullets, which are kind of like these quizzes for medical students.
Right.
And even the JAMA clinical challenges, which are based on real-world cases.
Wow. So real life scenarios, not just like theoretical textbook stuff.
Yeah, absolutely. It's a really good testing ground.
That's amazing.
And what they found was that, with this inference time scaling, the accuracy of these AI models jumped significantly. Like, we're talking improvements of 6 to 11%, even with a somewhat limited training data set.
Okay, so 6 to 11% might not sound like a lot, but when we're talking about, people's health, that could be the difference between a timely diagnosis and a missed opportunity.
Exactly, exactly. And that's why this research is so exciting. It really hints at a future where, AI could play a much, much bigger role in helping doctors make faster, more accurate diagnoses.
And potentially freeing up doctors to focus on what they do best, right?
Yeah.
Which is patient care.
Exactly right. And the researchers highlight two methods in particular that are showing a lot of promise. They're called long step and long monologue.
Okay.
And these methods essentially encourage the AI to generate these incredibly detailed explanations, almost like a doctor thinking out loud.
So it's not just about getting the right answer. It's about understanding, like, how the AI got there.
You got it. That transparency is absolutely vital if we're going to, trust these AI systems with something as important as medical diagnoses.
Right, because we're not talking about AI replacing doctors.
No.
We're talking about AI working with doctors.
Yeah, a partnership.
To provide the best possible care.
Absolutely. And there's a case study mentioned in one of the papers that really, really highlights this. And an LLM using this long monologue approach successfully diagnosed Erdheim-Chester disease
Okay.
in a patient with a really, really complex medical history.
And Erdheim-Chester disease, that's a pretty rare one. Right?
Incredibly rare, yeah. And what's fascinating is that the AI really meticulously analyzed every bit of information, ruled out all those other potential conditions, and arrived at that correct diagnosis through a very human-like process of elimination.
It's like the Sherlock Holmes of the AI world.
That's a great analogy. But even Sherlock Holmes, he needed the right tools and knowledge to crack a case.
Right.
And it's the same with these AI systems. Their effectiveness depends on a few key factors.
Over what?
Well, one is the capacity of the model itself. a bigger, more powerful model, you can think of it like a bigger engine, is going to be able to handle more complex tasks.
Okay, so size matters in the AI world.
Yeah.
It does. It does. What else? Oh, the complexity of the medical task itself, harder tasks like, diagnosing rare diseases, require these longer chains of reasoning. It takes more time for the AI to really connect all the dots.
So inference time scaling is especially important for those really tough, like really challenging cases, gives it the time to do its detective work.
Precisely.
What else is important?
Well, just like a human doctor,
Yeah.
the AI needs that solid foundation of medical knowledge, right?
Okay.
If it doesn't understand the basics, it's going to really struggle to draw the right conclusions.
So it's not just about raw processing power. It's about having that specialized, like, medical expertise built in.
Absolutely.
Yeah.
Absolutely. And this is where things get really interesting, right? Because now we're talking about the potential for AI to become this true partner to doctors, helping them make these faster, more accurate diagnoses, and ultimately, improving patient care. Okay, so we've got these super smart AI systems. They can reason like doctors. But how does this actually all play out in the real world? I mean, what are the implications for healthcare, like for the entire system?
That's the million-dollar question.
Yeah.
And that's what we're going to really explore in the next part of our deep dive. We'll look at the potential economic impacts, the challenges of actually integrating AI into healthcare, and the really big question of what this all means for the future of the doctor-patient relationship.
All right, folks, we're just getting warmed up. Stick with us as we go even deeper into the world of AI and healthcare. So we've established these AI systems, the ones with the inference time scaling.
Yeah.
They really have the potential to change things in healthcare.
Yeah.
But AI doesn't exist in a vacuum.
No, it doesn't.
How does this tech actually fit into the system that we have?
Well, that's a great question, and it brings up a crucial point. The human element. While AI can be an incredibly powerful tool, it's not about replacing doctors entirely.
Right. So we're not talking about like a future where you walk into a clinic and there's like a robot doctor.
Right. Not quite. Not quite.
Okay.
It's more about AI augmenting the skills of those human physicians, helping them make more informed decisions and providing a higher level of care.
So doctors are still very much in the driver's seat,
Yes.
but they've got this super smart AI co-pilot like riding shotgun with them.
Yeah, exactly. Think of it like having a team of expert consultants available at your fingertips.
Right.
The AI can analyze those massive amounts of data, identify those patterns, and even suggest potential diagnoses or treatment options. But ultimately, the human doctor is the one who interprets that information, considers the individual patient's needs, and makes the final call.
Right. So it makes a lot of sense. It's like having a second opinion.
Yeah.
But from an AI that's been trained on, all of medical knowledge, essentially.
right.
But this kind of partnership, it requires a whole new set of skills. Right?
It does.
I mean, for the doctors working with the AI and for the people developing it.
Absolutely. On the doctor's side, it's not enough to just know how to use the technology.
Right.
Physicians really need to understand how these AI systems work, what their limitations are and how to interpret their outputs critically.
Right. So it's not just about plugging in symptoms and accepting whatever the AI spits out.
Yeah.
Doctors, they need to be like AI literate.
They do. They need to be able to ask the right questions, evaluate the AI's reasoning, and really factor in other important considerations that the AI might not be aware of, like, for example, the patient's personal preferences, their cultural background, or social circumstances.
Right. And this brings up another point, right? The data.
The data.
Because these AI systems, they're only as good as the data they're trained on.
Absolutely. That's critical. If we want AI to be truly effective in healthcare, we need to make sure it's trained on diverse, high-quality data sets that are really representative of the real-world patient population.
Okay.
And that data needs to be constantly updated to reflect the latest medical knowledge and advancements.
So it's an ongoing process. You can't just train the AI doctor once and set it loose.
No.
It's got to be continually learning.
Exactly. And this is where the collaboration between, the doctors, the data scientists, and those AI developers becomes so important. It's this continuous feedback loop.
Right.
Doctors providing insights from their clinical experience, data scientists ensuring the quality and relevance of the data, and AI developers refining those algorithms to make those systems more accurate and reliable.
Yeah, it sounds like building a successful AI-powered healthcare system It's a massive team effort.
It is. It is. And let's not forget about the role of patients in all of it.
Right. The patient.
Yeah, they need to be informed about how their data is being used, understand the potential benefits and risks of AI in healthcare, and feel comfortable asking questions and expressing their concerns.
So we're talking about a pretty significant shift in the entire healthcare landscape.
Yes, we are.
How do we even start to prepare for this kind of future? Where do we start?
Medical education is a good place to start.
Okay.
We really need to integrate AI concepts into the curriculum from day one.
Right. So future doctors need to be comfortable with AI from the get-go, not just like the tech itself, but like the ethical considerations, the impact on doctor-patient relationships, all that.
All of that, absolutely. And it's not just about new doctors either.
Okay.
We need to provide continuing education opportunities for those practicing physicians as well.
Right.
This field is evolving so rapidly that it's essential for doctors to stay up to date on the latest advancements.
It sounds like a massive undertaking, but if we get it right, the potential benefits they're huge. I mean, we're talking faster, more accurate diagnoses, more personalized treatment plans, and ultimately, better health outcomes for everyone.
And let's not forget the potential for cost savings, right?
That's a big one.
By reducing misdiagnoses and unnecessary treatments and hospital readmissions, AI could really help make healthcare more affordable and accessible.
Right. Especially as healthcare costs just continue to rise. That's a huge, huge thing.
It is.
So we've talked about the potential benefits, but what about the challenges? What are some of the roadblocks we need to be aware of?
Well, one of the biggest challenges is ensuring that these AI systems are truly, truly reliable and trustworthy.
Okay.
After all, we are talking about making decisions that could have a profound impact on people's lives.
So no pressure on the AI developer?
Yeah, right.
But seriously, how do we build that trust?
Well, it starts with rigorous testing and validation. We need to put these AI systems through their paces, make sure they perform well in real-world clinical settings, and that their recommendations are consistently accurate and safe.
So no cutting corners when it comes to patient safety?
Absolutely not.
What else?
Well, we also need to address the issue of bias.
Okay.
Because AI systems are trained on data, they can inherit the biases that exist in that data.
Oh, wow. That's a scary thought. So if we're not careful, we could end up with AI doctors that are like perpetuating existing healthcare disparities.
Exactly. And this is where the diversity of the data comes in, right? We need to make sure that these AI systems are trained on data that represents a wide range of patient populations, taking into account things like age, gender, ethnicity, socioeconomic status, geographic location.
So building a truly equitable AI-powered healthcare system,
Yeah.
It requires us to be very thoughtful about the data we use.
Yeah.
Anything else?
Well, we need to make sure that these AI systems are transparent. Doctors need to be able to understand how the AI arrived at its conclusions, not just accept its recommendations blindly.
Right. It's like that old saying, trust but verify.
Exactly.
Especially when it comes to something like healthcare.
Absolutely. And this transparency is also important for patients.
Huh.
They have a right to know how AI is being used in their care and to understand the reasoning behind any diagnoses or treatment recommendations.
So it's not just about building trust in the technology itself. It's about building trust between doctors and patients and these AI systems that are becoming more and more integrated into healthcare.
You've hit the nail on the head.
Yeah.
It's about creating a system where everyone feels informed, empowered, and confident in the decisions being made.
Yeah, it's a tall order, but it sounds like a future worth striving for. So we've talked about the potential, the challenges, and the need for collaboration, but where do we go from here? What's the next step in this AI healthcare revolution?
That's what we'll delve into in the final part of our deep dive. We'll explore some of the really exciting applications of inference time scaling that are already starting to emerge from telemedicine to drug discovery and beyond.
Sounds like we got a lot more to unpack.
We do.
Stick around, folks, as we continue our exploration of the future of AI in healthcare. Okay, so we've talked about this potential of AI with inference time scaling, to transform healthcare.
Right.
But let's get specific.
Yeah.
Where are we actually seeing this technology being used right now?
Well, one area where it's already making a real difference is telemedicine.
Oh.
Imagine you're a patient, you're living in a rural area, hours away from a specialist.
Hmm.
With these AI-powered telemedicine platforms, you could have a virtual consultation with a specialist, and the AI could be working behind the scenes to assist that doctor in making a diagnosis.
So the AI is like this silent partner, right?
Yeah.
Analyzing symptoms, medical history, even test results,
Yeah, exactly.
and then providing insights to the doctor in real time.
Yeah, exactly. It can flag potential red flags, suggest additional tests, and even generate a list of possible diagnoses with really detailed explanations of the reasoning behind each one.
That's incredible. It's like having a team of specialists on call, no matter where you live.
It really is.
What other areas are kind of ripe for this type of AI integration?
Another area where we're seeing a lot of potential is the emergency room.
Oh, the ER.
ER doctors are often faced with making these really, really tough, life or death decisions in a matter of minutes.
Right.
AI with inference time scaling could be a real game changer in those high pressure situations.
Yeah, I can see that. How would that work in practice?
Well, the AI could help with things like triage, quickly assessing patients to determine the severity of their condition and who needs immediate attention.
Right.
It could also assist with diagnosis, analyzing patient data and suggesting potential causes for their symptoms.
So it's not just about speed then, it's about providing the ER doctors with more information, right?
Yeah.
To make the best possible decisions.
Precisely. And this kind of AI assistance could be particularly valuable in cases involving rare or complex diseases that ER doctors might not encounter very often.
Right, that makes sense. So if
Yeah.
the AI can analyze a patient's symptoms
Hmm.
and compare it to this, vast database of medical knowledge,
Mm-hmm.
it could help doctors consider diagnoses they might not have thought of otherwise.
Yep. Exactly. Exactly. And even in those more common cases, the AI's ability to process information quickly and thoroughly could really help reduce the risk of misdiagnosis or overlooking those important details.
So we're talking about the potential then to improve both the speed and the accuracy of care in the ER,
Yes.
which could have a huge impact on patient outcomes.
Absolutely, absolutely. And beyond those immediate applications, we're also seeing the potential for inference time scaling to really revolutionize fields like drug discovery and personalized medicine.
Okay, now we're getting into some futuristic stuff. Tell me more.
Well, in drug discovery, AI could be used to analyze these massive data sets of molecular structures and biological pathways to identify promising new drug candidates.
Okay.
It could also help predict how different drugs might interact with each other or with a particular patient's genetic makeup.
So we're talking about the potential to develop new drugs, faster and more efficiently, and to tailor treatments to individual patients.
Exactly. And this personalized approach to medicine is really where things get exciting. Imagine a future where doctors can use AI to create treatment plans that are specifically designed for your unique genetic profile, your lifestyle, your medical history.
It's like having a healthcare plan that's as unique as your fingerprint.
That's a great analogy.
Yeah.
And it's not just about treatment either. AI with inference time scaling could also be used for early disease detection and prevention.
Oh, wow. Okay, how so?
Well, by analyzing those large data sets of patient information, AI could identify patterns and risk factors that might indicate a higher likelihood of developing certain diseases.
Right.
This could allow doctors to intervene earlier, potentially preventing the disease from developing in the first place.
So we're talking about a shift then from reactive care to proactive care.
Yes.
Instead of waiting for people to get sick, we're using AI to identify potential problems before they even come up.
Precisely. Precisely. And that has the potential to not only improve people's health, but also to reduce healthcare costs in the long run.
That's incredible. But with all this potential, it's important to remember that AI is still a tool.
Yeah.
It's not like a magic bullet
No.
that's going to solve all of healthcare's problems overnight.
Absolutely. As with any new technology, we need to be thoughtful about how we implement it, address potential risks, and ensure that it's used ethically and responsibly.
And that's something we need to keep talking about.
Yes.
As AI becomes more and more integrated into healthcare, it's essential for doctors, patients, policymakers to have these these open and honest conversations about the implications of this technology.
I couldn't agree more. This is a journey we need to take together.
Yeah.
And the choices that we make today will really shape the future of healthcare for generations to come.
I think that's a great place to wrap up our deep dive into inference time scaling in healthcare.
It is.
We've covered a lot of ground today, from the technical details of how this technology works to the potential benefits and challenges of integrating it into the healthcare system.
And as we've seen, this is really just the beginning.
Yeah.
The field of AI in healthcare is evolving so rapidly, and we can really expect to see even more exciting developments in the years to come.
So to our listeners, thank you for joining us on this journey.
Yes.
We hope you've gained a better understanding of the potential for AI to transform healthcare and the importance of approaching this technology with both enthusiasm and a healthy dose of critical thinking. We'll see you next time for another deep dive into the cutting edge of science and technology.